All right, welcome to the dirty world of soils. All right, soils is dirt. Just for the record, don't ever call dirt to a soil scientist because dirt is soil out of place. Basically, if you have soil on your kitchen floor, then it is dirt, or in your carpet, or wherever. But on the ground where it belongs, it is always soil, not dirt. All right, that'll make them mad. If you want to get them mad, that's a good way to do it. Anyhow, let's talk about soil. Now, soil a lot of times to a geologist is just pieces of rock that are so small that they're no longer significant to him anymore. But soil is also the thing that allows us to grow crops, and without crops, we'd all be dead. No plants, no us. So it's pretty important stuff. Okay, so we're going to go ahead and spend a little time talking about soil because it's one of the most important parts, I think, of geology because geology, rocks yield us soil. So what are soils, first of all, and where do they come from? All right, soils are formed by weathering. We've talked about weathering a little bit when we talked about rocks and so forth in chapter 28 with the outlook of the land. So, what shapes the earth? Weathering is just things caused by the weather or breaking down of rocks. Okay, and so when things break rocks down in smaller pieces, that is called weathering. It's called weathering because many of those are related to the weather. Okay, for example, rain, water erosion that comes from that, the wind, and so forth. It could also be plants, roots, and so forth that break rocks down into smaller pieces. You've maybe seen a tree growing out of a rock and splitting it in half as the roots get bigger and bigger. And so as the roots go down in, they break little patches of lichens on a rock. All of those things are things that help break down rocks. So we got freezing water. If water gets down in a crack, then it freezes and it expands, just like if you have it in a jar in the freezer and it cracks open and breaks it open because it expands. Same thing can happen. Rivers, running water, heating and cooling. If you've ever been to Enchanted Rock, very large mountain, and basically at times you can hear noises. Basically, it's just the rocks heating and cooling, and it cracks off and you'll see little layers that just over time slide off and then make big rock piles down here. But it's basically from just heating and cooling, okay? And so forth. So it takes a long time to replace soil. If we abuse it and cause it to be eroded away or to blow away and so forth, it can be destroyed fairly quickly. But it takes many, many, many years for rocks to break down and form soils, and therefore it's very critical that we not just destroy it. Now, when we talk about soil and what it is, there are basically four main parts. Okay. So you have four parts of soil, okay? And the first is just the actual rock particles, okay? And normally, this is what we think of when we think of soil, because little tiny pieces of rock. If you were to look at soil under a microscope or a magnifying glass even, it just looks like little tiny rocks, okay? Now, we can usually only see with the naked eye, we can only see the large soil particles, which we'll talk about in a minute, but things like sand and stuff. But some of the smaller soil particles may be stuck on the side, little dust particles on the sand particles or whatever. And so it can be from fairly small pieces, but these are just pieces of rock. Okay, that's the actual mineral part of the soil. Okay, however, there's also a very important part is the organic matter. Okay, organic matter. All right. As leaves die and pile up and break down and decompose over time, there's organic matter, and worms and other things may work this organic matter down into the soil. Now, as you get deeper, you would expect to find less and less organic matter because it can't get too far deep in there, although, like I said, worms and other things help work it into it. Now, when we say this, organic matter just means things that were alive. Okay, organic, we're used to that word. Comes from living things. So it can be things like leaves and stuff from dead plants, or it can be roots and so forth from living plants. It can be animals, worms, grubs, slugs, snails, anything else that might be living down in there, mice and prairie dogs and whatever else may dig holes through there and help mix it up. Ants do a lot of mixing of this organic matter into the soil and bringing dirt up to the top. We should, would be complete a lawn if we didn't have a couple pile of fire ant mounds there, But they do a lot of job of mixing all that stuff together, okay? And that's the organic matter. Then we have, if we were to have soil particles, let me just pull a picture down real quick, okay? Or not. Okay, here we go. There we go. If you have soil particles, the other part, besides the actual organic matter or whatever, is there's a lot of spaces in here. Okay, and those spaces are called the pore spaces. Okay, as opposed to the rich spaces. No, just kidding. There are no rich spaces, but pore in this case means openings, just like the openings in your skins or pores. Well, these are pore spaces. And these pore spaces, we can have two other parts. Either we have water. Okay, water. If it's waterlogged, you could just have water filling up all the spaces below this, okay, and all of that's filled up with water, okay. Even if it hasn't rained lately, there will almost always be like a little film around of water around these. And so when we talk about soil water, even though the soil may appear to be dry, there's always going to be this little film around some of these. Now, if it gets too close to this, some of that the plants can take off of them and use that water, but eventually it gets to the point where that water layer is so thin and there's not enough of it, the plant can't pull it away from it, and basically the soil is dry and the plant may begin to die. But that's this water in the pore spaces is what our plants need and keep them from withering and whatever. Okay, now if there's no air around it, these spaces can be full of air, and we don't think about plants as needing to breathe, certainly not plant roots. You think, well, the leaves are up in the air and whatever, but plants also need to have air spaces. So when their roots come down into here, like we see these roots down here, they must have these little air spaces to get. In fact, many plants, if the air spaces are underwater, say you have a front yard and a low spot in your yard and it puddles up all the time, then it may drown some of those plants. Some plants can handle it for a short time, some for a longer time. Some, like rice, have to have their roots underwater for them to survive, and they can get oxygen from that, just like fish can get oxygen out of the water. But a lot of plants cannot, and if they stay underwater very long, then basically their roots drown, literally drown, and they don't get enough oxygen and they die. So the four types of four parts of the soil are the rock particles themselves, the mineral part, any organic matter, dead or alive, that might be mixed in with it. And in the pore spaces, you either have water, which is essentially have a certain amount of that, but not too much, and air. Okay, and so the roots are going to need both air and water in those soil pore spaces. All right, they get nutrients from the organic matter, and the rock particles also give off some minerals and stuff that the plants need, as well as providing something for it to stand up in, right? So all those things are good things that soil does for us. Now, when we talk about soils, not all soils are the same. All soils are different, and very often this can be why maybe something grows in one part of your yard, but it won't grow very good in another part of your yard. We tend to think, oh, it just wasn't a good plant or whatever, but a lot of times it has to do with the soil. The soil, all soil is not the same, okay? And we can separate soil by putting it through sieves, which are basically just round screens, okay? And they have different size openings. Now I can't draw very fine openings, but some of them are extremely tiny. If you look at the sieve, it looks like pretty much a solid piece of metal, but it's got little tiny holes in it to let little ones, and they get bigger and bigger. And we'll show you one of those in class, and we'll sort some out. But we can sort out the different size particles using these screen sieves. Okay. Now, to be honest, some of these particles are so small they stick to the bigger particles, so you really can't sort them out as well. In fact, sands do the best for this sorting out. As they get much into silt and clays, which we'll talk about, they're so small that they don't do that. So what they can do, they can actually run electric current through it, and based on how well it conducts electricity, they can estimate how much of these different soil size particles there are. But let's just go over real quickly. Three sizes of soil particles. You've probably heard of these. Three sizes of soil particles. Number one, let's start with the biggest, are sand particles. Okay, these over here would be a good example of sand particles. Now, when we say the large, keep in mind these are way oversized. You might see one the size of a period in a book, a little printed period in a book. That would be sand, but it could be a lot smaller than that. When we sort out sand, you'll see that some of the still considered sand, feels almost like talcum powder. Okay, and silt and clay are even smaller than that. But anyhow, sand are the largest particles. As the largest particles, then they have lots of pore spaces, because when they touch each other, there's going to be lots of space in between them. Okay, and so they have very large pore spaces. If you rub it in your fingers, it feels very gritty, okay, very rough, hence sandpaper. I mean, that's why we call it sandpaper, because it's fairly large, and so it will feel that. If you try to squeeze it together in your hand, it will kind of just fall apart, okay, because they're so big they don't bind together very good. All right, and because of these large spaces, they are very porous, okay? They will allow water to permeate, okay? So we'll say they're very permeable to water. It allows water to go quickly, but it doesn't hold on to it. The pore spaces are so big, a lot of it goes down. So plants that live in sandy soil send it in deep roots, okay? Because the top little bit of the sand may not have a lot of water, but there is water deeper down in it, and so they tend to send deeper roots. And some of these help build sand dunes and stuff like that on the beach where you see lots of sand, okay? Silt, on the other hand, are medium-sized particles, okay? Silt, as a soil type, it's probably the least common of all of these. A lot of times when you hear about silt, they talk about when rivers flood. Here's your river flowing down the stream. As long as it's carrying all the silt with it, that's all stirred up, muddy, very muddy water. The Mississippi always has lots of silt. But if it's going down the river, normally it's in here in the river. If it flows over the banks, when it gets over here, it slows down and it dumps all that silt. It settles out, has time to sit still and settle out. And when it settles out, dumps about a foot of silt in people's homes. So when you hear about flooding, a lot of times they talk about how many feet of silt is dumped inside their thing. And so silt particles are going to be our medium-sized ones, and of course then they would have less pore spaces, but still still fairly good pore spaces and so forth. Now the last size is going to be clay. All right, clay and sand are probably the two biggest that affect the kind of soil you have, because they're more common, and we're here more common. The effects of them are more overwhelming. In fact, it doesn't take much clay to make a soil act like what we call a clay. They're extremely small particles. We have a picture here, but that's probably exaggerating their size, and they're also usually kind of flat things, okay? These are the extremely small particles. They're very small. Now they have two characteristics though. I mean, they're important. One, when they get wet, they swell, okay? That doesn't mean they're swell when they're wet. That means they swell and get bigger when wet. Now, it already has very small pore spaces, but if these swell up, then there becomes practically no pore spaces. Water cannot get through, and these are soils where water just sits on top of it and will not go through it. And if your water will not go through it, then these can be very yucky, messy soils. Okay, they're very sticky when they're wet. If you walk through the mud and it just cakes onto have like an inch of dirt, mud stuck on each side, it's probably clay. Okay, in my house at home, we have about a foot of fairly sandy soil, but then we have clay. And when it rains, if it rains a little bit, okay, well, it goes through the sand, that's fine. But once it hits this clay level, it doesn't soak in anymore and it starts piling up. And this gets very squishy up here above because it's sitting in water, basically, okay, and it puddles up really bad because this clay will not let the water go on through. And so we have what we call a clay pan or a clay layer, and that can be a problem. You have good water down to here, but then roots can't go down in this clay because it's so hard, and so it can be bad. And so the other thing is it swells when it's wet, but when it dries, it shrinks and it gets very, very hard. Most bricks are made of some type of clay type soil. Okay, so when it dries, it shrinks and gets very, very hard. Now, if you're building a house on this, it rains, it swells and gets bigger, it dries, it shrinks. You see in the summertime, you may see cracks that go down about a foot deep. That's this. And if that's doing it under your foundation, which is not supposed to move, then you may start getting cracks in your walls and things like that. And we'll talk more about that in our next video, but we're almost done with clays.